Okay, good evening. I apologize about the delay. I'm trying to make sure all technical issues have been sorted out and you guys can hear me clearly and also see my screen. All right. Mr. Christopher, please, if you can hear me loud and clear, please indicate. All right. So I know that I'm carrying everybody along. I don't know why I'm saying that the live stream is offline. Please, okay, I just received a message from Suleiman Ademola. All right. Please, before I proceed, I would like to confirm with my colleagues if I'm good to go. I apologize again about the delay. Okay, let me proceed then. Good evening, everyone. Welcome to our first class on Fusion 360, which is brought to you by Nigerian Society of Engineers Abeokuta branch in partnership with Royal Grant Engineering Training Limited. In today's class, we are going to talk about Fusion 360. What is Fusion 360? What is all about? The overview, everything you need to know about Fusion 360, its fundamentals, the Fusion interface, the interface of Fusion 360, and if we have time, we'll also try out one or two examples. My name is Ugu Henry Christopher. I'm a mechanical engineer by profession. I'm also a CNC machinist where I use Fusion 360 for design and manufacturing. And I will be your instructor for Fusion 360 in this training program. So before we proceed and dive into the world of Fusion 360, I would like to take out some minutes to talk about Royal Grant. Okay, so what is Royal Grant? Royal Grant Engineering Trainings Limited, also known as REnT for short, is a training institution or a training center that helps people, most especially students, graduates, and young professionals who are just getting into the field of engineering to learn those useful skills that they need to succeed in the industry. Okay, it's a common knowledge that there's a large skill gap in Nigeria engineering industry. There's a large skill gap from what we learn in school and what we actually practice in the industry. There's a large skill. Most graduates, despite their certificates, do not have that necessary skills that they would need to work in these industries that they will want to go into, and including some professionals, some people who are even working currently find out that along the line find out that they need some necessary skills that will give them that boost, or that will help them make their jobs or their work in their various industry to be smooth, but they do not have those skills. And as a result of this, so many companies, this is common knowledge, so many companies do outsource those specialized skills, those skills that are very important. They outsource it to foreigners. That's why you see them bringing in people like the Indians, the Pakistanis, the Chinese to come and be doing some specific tasks in our industry, in our companies here in Nigeria, despite the fact that we have thousands of engineering graduates and even working professionals that they cannot even use to do those things because we don't have the necessary skills, and we can't really blame them. So this gap now, this issue that we have in our country, this skill gap that we have in the engineering industry as a whole is what Royal Grant is trying to solve. Okay, this is one of the solutions we are trying to provide. So we are a training institution that makes sure you get those very necessary skills, necessary skills and the resources that you would need to scale up in the engineering industry, that you need to scale up in our industry. So it's even when you for those who are currently working, they can attest to this. That even when you are done graduating, you graduate, you get your certificate, and you start looking for a job. So those jobs that we are said with regards to your various departments or branches of engineering, generic engineering courses like mechanical engineering, electrical engineering, civil. You also have petroleum engineering. All these engineering departments, which are um, general engineering segments or sectors like that, they do have this requirement, these skills that they require for those guys, even though they know you did not, or probably you are supposed to do these things in in your institutions, but due to our standard of education in Nigeria, we were unable to access some of these things, or we are unable to learn some of these skills. So, but it's very, very important. For instance, if you are applying for a mechanical engineering role, which is a generic engineering role, not even it's not even a specialization. You are applying for a job as a mechanical engineer. You will find out that in the requirements you will see stuff like we need someone who uses AutoCAD, we need someone who uses ANSYS. These are technical skills that are very important to them in those industries. And you as an engineering graduate, you think your certificate, or you've gotten your certificate, you have your first class, and or which is fine, which is beautiful, and you're trying to apply for this thing. You find out that even half of the requirement that you do not even meet it, despite the fact that you're a graduate of mechanical engineering. So that is a serious issue that we in Royal Grant are trying to solve. And aside from that, Royal Grant provide you with the medium to learn these skills at your own convenience, at your own time. Okay, it gives you that ability. Most persons or most Nigerian engineers or engineering students or engineering graduates do not have access to these skills, probably due to location. Okay, most engineering industries are located in places like Lagos, Ogun State, River State, and probably maybe Edo Delta. So these are few of the 36 states in Nigeria. And you are based in the northern part of the country, or in the middle belt, or in the eastern part of the country, and you don't have access to these training centers or these institutions that you can learn these skills from. Okay, the Royal Grant gives you that ability. That's why our trainings are mostly virtual, so that anywhere you are, any location you are in Nigeria, whether you are in Nigeria or you are not, you are in Ghana, you are in Pakistan, anywhere you are, any location you are, you can always tune in to our class and try to upskill yourself. So we create that convenience for you. And also our training modules makes it convenient for you, for those who are already working. We have some working professionals here who would like to upskill, but the timing of most training institutions might collide with or clash with your work time or the time you are currently working, and you might not have that time. Okay, you can't say, oh, because I'm trying to upskill, let me resign and go and learn the skill. No, it's very you can that's not a plausible decision. So you have to look for a medium where you can upskill yourself without having to lose your job or having to resign. And Royal Grant provide that platform for you with our virtual trainings at your own time. You have the ability to learn at your own time. If these our classes, you can, from the information we dropped in the group, our classes are being recorded for those who are unable to attend. Okay, you might, or we have classes by 8:30, but you probably came back late from work, and you got too tired, you are unable to attend the class, and you think you probably missed out or something. You won't, because most of our classes are recorded and made available to you. We also provide other resources and mentorship that will help you, guide you in your upskill journey, and in trying to upskill yourself and succeed in the engineering industry. This is what Royal Grant is all about. Okay, now let's dive in proper into Fusion 360. Okay, so let's start by defining what Fusion. Today's definition is a comprehensive cloud-based design and manufacturing. It integrates various design and engineering tools, including CAD, which is computer-aided design for designing, CAM, computer-aided manufacture for manufacturing. Okay, CAE, computer aided engineering for simulation and analysis, and PCB, printed circuit board for electrical and electronics engineers, all within a single platform. All these things, both the CAD aspect, the manufacturing aspect, the analysis aspect, the electrical engineering aspect, all these design process are being compiled in a single platform known as Fusion 360. This allows the users to work on their design, simulation, and manufacturing process without switching between different software. Initially, probably 5, 10 years ago, softwares, design softwares or engineering softwares are separate. Like, you have a particular software for your design, you have a particular software for if you want to run your analysis and simulations, you have a separate software for that. If you want to do your computer aided manufacturing, you are trying to manufacture, let's say you want to program a part for milling, you want to carry out a milling operation, you want to carry out a turning operation that is using lathe machine, you want to 3D print, you want to carry out laser operation, plasma cutter, you want to work on your PCB, create PCB, printed circuit board. All these engineering softwares are separate. Even currently, they are also separate. We have individual software for all of this. But Fusion Autodesk came and said, oh, this entire design process, you find out that as an engineer, while working, you would need varieties of software to complete an entire design process, both right from the ideation stage to the final manufacture and documentation stage. So what they did is that they decided to combine all these functionalities in one software known as Fusion 360, and is a cloud-based software, meaning that all your data and files can be saved in the cloud, okay, like cloud storage, and it gives you the ability to document your data, files, and designs. Okay, Fusion gives you that ability, the cloud, so you cannot lose your file. So the moment you start using Fusion 360, there is no way or situation where you can lose your file, even if you don't even save your file. By default, Fusion saves it for you. Okay, so let's say you are working on this on a design and you forgot to save, your system went off. By the time you log in, by the time you power up your system again and log in, you will find out that your designs are there. They didn't you can't lose it because of this cloud-based functionality. And also most of these design and analysis processes requires high computer resources and computations. Okay, and our laptops here, our PC might not be strong enough to carry out these calculations. Okay, sometimes even when you try to do that, if you notice, those of you who have been using engineering softwares, you will notice that along the line, while you are carrying doing a design or a calculation or this, whether MATLAB and co. Whenever you are doing, you will find out that your system begins to lag, okay? Because the power of your system, the resource your PC resources cannot handle that calculation effectively. Okay, so Fusion 360, because it's a cloud based, it now gives you that ability to not use your own PC resources, that is your system power or processor, to do those calculations. You can do those calculations now in the in the Fusion or Autodesk cloud-based server. Okay, so those calculations are being done in the cloud. So you don't have to stress your system anymore. You don't have to stress your system or your PC whenever you are doing any design, because there are so many design processes that require high computation, like in generative design using AI to generate designs for you. It requires a lot of computation, and it's going to require a lot of resources because it's going to generate as many designs as you want, allowing you to select anyone you like. Also in simulation, when you are carrying out analysis and simulation like structural analysis on a system or on a design, you want to carry out structural analysis, thermal analysis, all this requires strong computational cost or high computational cost and resources, and these things might cause your system to lag, and your system might not be able to run these calculations effectively. So those things, if you are working on the cloud storage, you have the option to always carry out those calculations or solve those problems in the cloud without using your PC resources. So while it's solving in the cloud, you don't have to wait because your system is lagging. Okay, you don't have to wait because your system is lagging. You can just send it to the cloud for it to solve. Then you go on with and carrying or doing another design. All right. So that's the definition of Fusion 360. So you can use it for both CAD design to create any design or 3D geometry of your choice. Also use it for manufacturing with when we were in school we were using machines, but most of them are manual. You have the CNC version where you have to program these things in a software, send the G code, and the machine produces everything for you in the form of like an automated CNC machine. So you can use Fusion 360 for your manufacturing. It's not just limited to milling and lathe. You can also use it for 3D printing, use it for fabrication, laser operations, plasma cutters, so on and so forth. So you can also use this system to create PCB, that is printed circuit board, and electronic components. Fusion gives you that ability. You can also use Fusion 360 to carry out structural analysis on a system, okay, to determine the stress, deformation, factor of safety, and the like. You can also use your Fusion 360 to convert your 3D models into 2D drawings, okay, for manufacture purposes. Okay, so let's dive into Fusion 360. Like I said at the beginning of the class, that we are going to talk about. I'm going to introduce you rather to Fusion 360, where we'll talk about the interface. We're introduced to sketching, how to use the drawing tools, profile creation, solid creation, creating solid from surface from sketches. Okay, so before we proceed with an example, let us launch our Fusion 360. Okay. So this is the Fusion 360 interface. This is the Fusion 360 design interface. Whenever you launch your Fusion 360, it opens up the design interface by default. Okay, you have different workspace. This is the design workspace. You have different workspace. Remember, I told you Fusion is integrated and PCB integrated, and it's also a cloud storage, meaning that you can store and manage your data in the cloud. Okay, so as you can see from the top left, at the very top of my screen, you will notice this here, which is my name and the type of fusion license that I'm using. So this is the Fusion personal license, which is the free version of Fusion 360. You can see this is the free version of Fusion 360. So that's why whenever you are using the free version of Fusion 360, you will notice that the generative design, the simulation are both turned off. Okay, they are both turned off. These are only available to those that are using education license. Those people that are using education license and those ones that are using the paid version, which is the commercial use. Okay, while education license is also free, like I told you earlier during installation, that you have three licenses. One of them, we used to have four initially, but now it's now three. The personal license is completely free. Okay, but there are some features are deactivated. Like here, our design, generative design and simulation is deactivated. You also have the education license. That one is also free, but it's renewable. You need to use your education. That education license is for both students and educators alike. Okay, but you also need to show proof that you are a student. So is that one is renewable every year. Once a year, you have to renew it once a year as long as you're a student or educator. And for that Fusion education license, everything is unlocked for you. You have access to every Fusion 360 functionalities. Okay, the third one is the commercial license, which is the paid version. Okay, being used by businesses. All right, so that is all about Fusion license. Okay, so the next tab here that I would like to point out is just at the top left corner is your file menu, where you have the data panel where you can have access to all your cloud storage. This the data panel is also known as your cloud storage. You can create projects, save your cloud, you can create folders, save all your documents to the cloud, save detail. Like you have access to use and manage your documents in the cloud. So this is what this data panel does. This is your cloud storage. This is where you have access to your cloud storage. If you can also open it in, you can also open this also in your Google Chrome. Okay, so you have the option to open it in your Google Chrome. All right. So if I'm connected to the internet, you will see a little browser icon here where you can go in by left clicking on that, it will redirect you to your Google Chrome for you to access all your files. You can also access one is your um, file tab where you can create design, open new design, save your file, export. Mind you, whenever you are saving to the cloud. Whenever you use this save option here, you are saving to the cloud storage. But whenever you want to save to your computer, that is your PC that you are currently using, that is offline saving, you use export. So export is to save to yours. You cannot export until you save to the cloud. So Fusion make sure you doesn't they put in all these functionality so that you are not, so that you don't lose your file as a result of one reason or the other, an accident, or you lose your PC, or even if you end up on your computer. When you get another one, you can always log into your Fusion 360 account and access all your file. You can't lose your file whenever you're using Fusion 360. You cannot. That's the beauty of it. That's why I told you it's a cloud storage. You can't lose your file. Okay. So before you export to your PC, it will prompt you to save to the cloud first because it doesn't want you to lose that file due to one reason or another. You can't lose your file, so you have to save first before you export. The third icon there is the save icon. Okay, rather than going through this file tab, you can also click the save icon here. Then this tool is the undo and redo button where you can use to go back and move forward, just like Control Z. Okay, then you have the home. This home will direct you to your this home will also direct you to your files data management system. Okay, so the next section in Fusion 360 is just below that file menu is your workspace tab. Okay, in this workspace tab, you can switch between workspace. So by default, whenever you open Fusion 360, the design workspace is being activated. So this is the design workspace. All right. So the first one is the design workspace. If you are using the education license or the 30-day trial or the commercial license, these other ones will be open for you. This generative design and simulation will be active. So the second one is the generative design where you use AI to generate. Fusion uses AI to generate designs for you. So you just tell them what you want and how you would want your design to be. You just give it an idea. So Fusion will use its AI system and generate designs, different designs for you where you can tweak it to the exact thing you want, or you select the one you want if you're okay with the final product. Then you have the render for creating realistic images of our design. That's what the render does. Then you have the animation. Animation can be used to create assembly bodies of our design. If you if or should I will say an exploded view. You can use animation. It's a very powerful tool. It's like a video creation tool where you can use and you can use animation to simulate or animate what your model or assembly looks like or how it functions. Okay, you can also use it to create exploded views. If for those that are creating drawings for manufactured parts, okay, you can use animation to create exploded view, which you now have to now import to your drawing workspace. So you have simulation. Simulation is used to carry out analysis and simulations such as structural analysis on beams and system. You have thermal analysis to simulate the temperature distribution on the body. You have your event analysis, and there are so many of them. Then you have the manufacture tab, which is the one I use in my work. I told you I'm a CNC machinist. I use Fusion to design and manufacture. Okay, so you have the manufacture. If you want to go into milling or late operation, this is the late, this is under turning. Then you can see milling for milling machines. You have turning for lathe machines. You have additive for 3D printing. You also have other functionalities there also. Then you have your drawings. You can also create drawings from your 3D models. Okay, so you have the option to create drawing from your design or from your animation. Remember, I told you if you want to create exploded views and use it to create drawings, you can do that in animation. And then when you want to create a drawing, you say you want to create a drawing from that animation. Then you have the electronics workspace for electrical and electronics engineers for creating PCBs, PCB design and electronic components. Okay, so that's all about the workspace. So I'll switch back to the design workspace. All right, so at the just below it, you have our browser tab. Okay, this is your browser tab. This is your browser tab where every operation you carry out is being saved here. For instance, you create not every operation per se, but every component, bodies and sketch you create will be displayed here on the browser tab. If you create a component, you have it here. If you create a body, it will be saved here as under the body section. If you create sketches, it will be saved under the sketch section. So this helps you. This browser tab is like a design tree. It helps you to organize your design. It helps you to organize and arrange your design. Okay. So at the bottom of our screen, we have our history tab. Okay, this is where every operation you carry out in Fusion 360 is being recorded. So it has this history tab. You can always turn it off and on. So in case if you want, you can turn it off. If you don't want, you can leave it on. So it's very I would advise to always leave it on because it gives you that flexibility to always go back and change something you don't like. Any operation you carry out will be recorded on this timeline, okay, on this history tab. They call it the history tab or the timeline. So that if you're probably you've gone far in your design and you don't like what a parameter, or you want to change a parameter before, or you don't like an instruction you did initially or an operation you did initially, you don't have to cancel everything and start the design from afresh. Okay, all you have to do is just go back to that operation on the timeline and edit it and just change the values or parameter or change the operation. Every other thing will update, putting that one into consideration. Every other thing will update together with that one. Okay, so it makes your design simple and easy to use. It makes your that's why most people or those who have used Fusion will always tell you that Fusion is the most user-friendly software they've ever come across. It's very easy to use. It's a very, very simple software, okay, especially for rapid prototyping, manufacture, and design, and computer-aided design. Fusion is a very user-friendly software. Okay, It's very easy to use. After today's class, you'll notice that you'll be able to create designs and sketches. All right. So at the top of our history tab, we have our navigation bar. Okay. For our navigation bar, we use it to navigate or change the orientation of our design. Like you have your pan to move your design. Let me create a simple sketch so that I will be able to illustrate this better. Okay. So I want to create a box. So I'll go to my create drop down menu and select the box. Let's click on the box to activate it. You have your three planes. Okay, you have to select a plane. You can always create a sketch on either a plane or on the surface of a body. But currently we don't have any body where we can select a surface, so we have to select any of this plane. So I'll select this plane here, then I'll place it at the center or anywhere. Let's click, drag, let's click again. So we have our box. Okay, so you can always adjust the feature. So whenever you are carrying out any operation here, okay, any solid operation, you have your, whether solid or not, any operation at all, you have your dialog box here. That operation, the dialog box. Remember, we activated the box command. So we have our box dialog box activated. Okay, you can always adjust it, tweak the values, and then say okay. Okay, so I wanted to use this to make an illustration. That's why I created that box. So for our navigation, the first on our navigation bar, the first tool there is your orbit tool. Okay, you have to type free orbit and constraint orbit. So you can use it to change the orientation of your design. Okay, just left click and rotate. You can use it to change the orientation in 360. Okay, you can use it to change the orientation of your design. While the next one is look at. Okay, you can use look at to select a specific aspect or a specific phase in your design that you want to work with. That's where you use your look at. All right. The next one is your pan. Okay, you use your pan to move it in X and Y direction. Okay, that's the pan tool. That's what you use the pan tool for. Then the next one is the zoom in and the zoom in. So when you select it, you can use your mouse, your scroll button to zoom in and zoom out, or you left click and drag in the positive or negative direction. Okay, to zoom in and zoom out. Okay, you also have other settings here. So but we'll leave that for our next class. So the next tool here is before we talk about these last two at the top, let's talk about the view cube here. It's an important tool. Just like the navigation bar here, you can use this view cube to change the orientation of your design. Okay, so sorry, let me close this operation here. This look at can left to close any operation, you left click and say okay. Okay, so this is our it's called the view cube. You can use it to change the orientation. It's mainly used for the to navigate or change the orientation of your model. So if I should click on this home icon here, it will change it to an isometric view. Okay, you can see it has been changed to an isometric view. All right. Rather than using this zoom in and zoom in to, you can use the scroll button on your mouse to zoom in and zoom out. You can also hold down the shift key, then hold down the scroll button to orbit. All right. So if you hold down the control button on your keyboard, control on your keyboard, and hold down the scroll button, you can pan. So you can, this is also a shortcut of using all these from all these functionalities or using all these commands. Okay, so back to our view. So you can use your view cube to select any part of your model, the orientation of a model. I told you the view cube is mainly used for the orientation, to change the orientation of your design. So if I should click on this top to turn to the top view of my model, if I should click on home again, it will change to isometric. If I should click on the front view, you can see that's changed to the front view. Okay, that's what we use the view cube for. Then at the before we move over to the toolbar, there at the top right corner, you have your extension tools. Okay, So the first one is Fusion extensions. If you want to attach any extension to Fusion 360, there are so many of them you can use it, but this is for advanced operations. Okay. Then the next one is your job status icon, job status button here. Where you remember I told you Fusion is a cloud-based storage, meaning that you can work online and offline. But for those of you that are just installing Fusion for the first time, Fusion might prompt you to work online for at least a week before you have the ability to switch to offline whenever you are working. Okay, so mind you, whenever you are working online, you are using your data, and anything you do will be saved in the cloud immediately. Okay, while anytime I'm working offline, anytime you are working offline, just like I'm doing now, when I'm done, and save my work, it will wait for the time I come online to be able to upload my files, those files that I saved when working offline. It will now send them to the cloud storage and save it for me online. So whenever you are working offline and you save, it will not be saved immediately. It will be kept somewhere. You don't lose it. Then anytime you connect your Fusion 360 to the internet, it will now upload those files that you saved to the cloud storage for better, storage and documentation. So you have the option to change between online. This is a button. You can always move it to work online or to work offline. Currently, I'm working offline. Okay. Then you have the notification center for your notifications. You have the help this thing, and you also have the preference tab. Okay, where you can change some settings or preferences of your Fusion 360 interface. Okay, you can always tweak this arrangement here. So the last but not the least, or the least but not the last, whichever way you say it, is the toolbar. Okay, which I would say is the most important part of Fusion 360 design interface. So this is what we call the toolbar, and it has different sections. You have the solid section for creating solid bodies. You have the surface section for creating surface bodies. You have the mesh if you are working with mesh bodies. For those that are into 3D printing, you understand what I mean about mesh bodies. Okay, you have the sheet metal if you are creating sheet metal bodies. You have the plastic if you are working on plastic bodies, and every other functionalities. Okay, so by default it is set to the solid body because it assumes you want to create solid body, but you can always switch in between interfaces. Okay, so in the solid body is divided into subsections. You have the create section where you have the create section where you have the create commands. Okay, several tools that you can use to create different solid models. You can use this create tool here to create anything. There is no geometry that I've come across that you cannot create with um, this create command here. Then you also have the modify, which modify commands which you can use to modify the designs that you've created. You also have assembly commands which you can use to create assembly or joint relationships, assemblies or relationships to your designs. Okay, if you have more than one design and you want to create assembly, for instance, for an example, you're an automobile, a car. Okay, when you design a car, you have the wheel. Okay, you want to create a relationship between the car body and the wheel, or the chassis and the wheel. Okay, and you also want to add a relationship to that wheel, that you telling the Fusion 360 that the wheel will rotate. Okay, you cannot creating a realistic object in your card software. So you can do that with Fusion 360. That's what the assembly does. You also have the configure for advanced operation. You have the construction, that is to create different planes. Okay, remember I told you that if you want to create a sketch, you can only create a sketch on a plane or on the surface of a body. So in case those three, by default, it comes with three planes. Okay, comes with three planes. These are the three planes. It comes with three planes by default, but Fusion gives you the ability to construct more planes in case these ones are not enough. Then you have the inspect tab. Okay, when you have the inspect, you want to measure your two distances. You have that. You want to check if there is interference. You want to check the center of the mass. You want to check the section analysis. Okay, also many functionality here. In our advanced class, we'll be talking about more of this. Okay, so this is like a fundamental class. This is a beginner course. All right. So where we introduce you, get the basic understanding of Fusion 360. In our advanced class, we'll be diving deep into all these functionalities. Okay, so also have your insert tab, your insert sub menu, and your select. Okay, so we'll talk more about that as we proceed. If you have any question, don't and do where to drop the question in the chat box. I will address them as time goes on. Okay. Please hope you guys can hear me. I want to make sure I'm carrying everybody along. Okay. So that is all about Fusion 360 interface. Okay. This is the Fusion 360 overview. All right. So our time is fast spent. So I would like to end this class by 10 o'clock. So I don't want to waste too much of your time. So we are going to proceed as fast as possible. So for the first example, I would like us to do this example. I created, or I rather, I did a recorded section on these examples, about two examples, and we made it available to you guys so that you can watch before this class and probably have a better understanding, so that when we are talking about these things, it will be easier for you to grab them. If you have any questions, you can then relay it to us and we address them also. So even this live class now is also being recorded and will be made available after the class. Okay. All right. So I'll make sure, and also we'll be dropping the attendance on the group, on the chat box, for those of you who are online. Okay, so you can fill your attendance, and the course code is Fusion Day One. Okay, so the course code for this class, the course code is Fusion Day One. Okay, this is the course code for this class. So whenever you are filling the attendance, there is a section for course code. So make sure you use Fusion Day One as make sure you use Fusion Day One as the course code. Okay, so let's proceed. So this is a very simple design. We're going to create this a simple design, a simple sketch, or a simple sketch design, and extrude it into a solid body, or convert it into a solid body. After that, if we still have time, we'll try out the second example. Okay, and also I also want to mention that after this class, we are going to provide, as you have to do as an assignment after each classes that we have here. So why we might not have the time to introduce the assignment to you. So after the class, the online session, we should end by by at most 10 o'clock. I will provide the assignment for you in the group. We'll drop the assignment to the group in the group chat, along with the instruction on how to submit them. Okay, for those of you who did not attend the AutoCAD class, okay, there is a medium of submission for our assignments, and it's very important. It's very important. Yeah, we keep track of all those things. All right. So we are going to drop the assignment in the group chat along with instructions on how to do them. All right. So let's proceed because we don't have much time. You are going to create. The first step is to create the sketch using these dimensions. Okay. So I'm going to start by creating a sketch. All right. I can either delete this one, clear this, or click on this plus icon to open up a new tab. Just like in your browser, in your phone browser, you can always open new tab, or close old ones. All right. All right. So the first step is to create a sketch. So how do you do that? You go to your create menu. Okay. Click on the create menu, scroll down to create sketch. or you can select it from the top here. It's available at the top. You can click on it, left click on it to create sketch. Then remember I told you that you can only create sketch on the plane or on the surface of a body. But currently there is no plane here. There is no body here, so we are going to create a sketch in any of these planes. So I will select this bottom. So you always notice that I'm always using the bottom plane. Don't worry, you can select on any plane. It doesn't really matter. Okay. So the next, all right, and apply this dimension. So I'm going. The next step is to we are going to try and replicate this using the Fusion 360 in the Fusion 360 sketch environment. Okay, if you notice, the moment we created a new sketch, selected the plane, the sketch environment was activated. Our sketch environment is activated. Okay, and when you are done using the sketch environment, you click on finish sketch here at the top of the toolbar or in this our sketch palette here. Scroll down to the bottom, you can see finish sketch. And when you finish sketch, it will take you back to the design environment. All right. So, but we are not done with that. So you want to go back to your sketch. Remember what I told you about the history tab here, the history tab. Okay, see our sketch. Because we created the sketch, it has been recorded here. So I don't need to undo or do or create a new one. I can just easily go back to that, right click on it and see and scroll to edit sketch. Let's click on edit sketch. So we are back to that sketch environment. So I'm going to create a rough this. I'm going to create this rough sketch. I won't add any dimension, then we'll add dimension later. Okay. So and in order to do that, you need your line tool. Okay, because this is just a combination of lines. So I'll go to my create, drop down menu, and on there. Let's click on it to activate it or using the L command. Alright, my line tool is activated, so I'll click here. I'll scroll. I told you I will just create a free sketch. Alright, alright. It might not be even be straight. That is not a problem. You can always fix that. Alright, just create a free something that is similar to that one. Okay, so we've created something like this. Of course, this is different from this. Okay, but we are going to use those tools, our modify tools and our constraint tools to make sure it's exactly like this. All right. Okay, so the first thing we are going to do is to fix some of these lines and make them accurate. All right. Just like we have in our design solid design interface, you have your create, your modify. But here instead of assembly, you have your constraint because you are working with sketches and you don't need assemblies in sketches. So you have your constraint. Constraints are relationships that you add to your that are being added by default, or you can add them yourself as a result of you creating sketch in your sketch environment. You can see all these symbols you are seeing here are constraint. This is a perpendicular constraint, making sure that this line is perpendicular to this line. Okay, so no matter how you move it, the line will always be perpendicular. So this a relationship between them makes your design much more professional and better. So this line is not straight, and all our lines here are straight. Okay, you can see all our lines are straight line, either vertical or horizontal. So we are going to fix that here. So this line is not vertical, is not straight. So we are going to add the vertical horizontal constraint, which is the first constraint here, horizontal slash vertical constraint. What it does is that whenever you add it to a line, it's going to make that line either vertical or horizontal depending on which one it's closest to. So if the line is closer to the horizontal axis, it's going to make it horizontal. If it's closer to the vertical axis, it will make it vertical. So that's what it does. You can see this line now is more vertical than horizontal. Okay, this line is not that. If the line was something like this, if the line was something like this, okay, if the line was something like this, you realize that this line is much more horizontal than vertical, but this one here is more vertical than horizontal. So when if I should use this horizontal vertical constraint and apply it to this line, it's going to make it vertical. The same thing applies to every other one. So I'm going to delete this line. Okay, I'm going to add vertical constraint to this and this. Okay, every other line is straight. So I'll click on constraint. Let's click to select the command horizontal vertical constraint. I'll click on this line. You can see now it is straight. And I'll click on this one also to make it straight. You can see our lines are now straight. So no matter how we move them, it cannot bend again. You can see them. You can see them. It can't bend anymore. They maintain that vertical and horizontal relationship. Just to make sure this bottom line is horizontal vertical, I'm going to try and add a horizontal constraint here. Okay, you can see they say sketch geometry is over constraint, meaning that you might encounter these errors. It does not mean that what you are doing is wrong. Okay, Fusion is just trying to optimize your design. All right, so it's this is perfectly vertical. So it is telling you that it's over constraint. There's no need to add another constraint here. So it's okay. So the next thing we'll do is to add our dimension. Now we have something similar to this shape. So the next thing is to add our dimension. So the first dimension we are going to add is the bottom dimension, which is 100 millimeter. So we are going to be working with millimeter, 100 millimeter. Then we add the second one, 40, and then 50. All right. And how do you add dimension? You go to your create drop down menu and scroll down to sketch dimension. You can activate it here or on the top or the toolbar here is present here. You can click on it to activate it or use the letter D on your keyboard to activate it. I should left click, my dimension tool is active. So I'll select this line, let's click on it, drag out, drag it out. Let's click again to open it to add that dimension. Now type in 100 and then enter. You can see that it has been that horizontal line on the bottom has been adjusted to 100. Okay, this is not fully constrained. This sketch is not fully constrained. Okay, there is a terminology used in Fusion 360 whenever you are designing. It's called fully constrained sketch and not fully constrained sketch. You are going to see the difference here. Okay, if your sketch is fully constrained, it means that you cannot move it again. You see the way I'm moving this one. If this sketch is fully constrained, I'll not be able to move it. By the time we constrain the sketch fully, you will not be able to move the sketch. So that along the line, along the line while you are designing, your design becomes more and more complex. All right. A change in that design is not going to distort everything. So it will now do another calculation and now arrange it relative to that constraint sketch that you have done. Okay. So rather than distorting everything, it will now adjust itself to make up for those size changes. Okay, but currently it's still shining blue. It's not fully constrained. It's still unconstrained, fully unconstrained. All right. So we've added this dimension. So the next one is to add the dimension from here to here, 40, and from here to the top, 50. So we are going to activate our sketch dimension. I will click on this line, click on this point, then drag it outside. Click again to open it and then say 40. I'll press enter. Okay, I will repeat the same thing for here. I'll click on this point or click on this line. You can always apply dimension between line and line, point and edges everywhere. You can apply dimension in all form and manner. So I will left click again to open it and I'll type in 50. Then I'll say enter. So we've gotten this. But if you notice, this line is long, this one is longer than this, but in our sketch, they are both collinear or they are in the same line. So but that's not a problem. We can fix that also. So whenever you encounter any problem, whenever you are designing in Fusion 360, always know that there is a solution. You can always fix them. So in order to fix this, I want this to be on the same line as this. I will go to my constraint and search for collinear constraint. Okay, this is collinear. I want them to be on the same line. So this one is dimensioned already. So it's going to push this one down to this one. So if I should click on this line and I click on this one, they are going to be collinear. And the collinear constraint have been added. All right, this is how you apply constraints. So the next step is to apply a dimension between this line and this line, 40 millimeter. This line and this line, 70 millimeter, which is the last dimension you are going to apply. All right. So I will activate my sketch dimension. Again, I'll apply between this line and this line, 40. Let's click 40, type in enter. Then I'll dimension again between this line and this line, 70. Type in and 70, type in enter. Okay, now we have our sketch. Okay, we have exactly what we have here. All right. But our sketch is now still shining blue. It's not fully constrained. You can move it on the canvas. Okay, you can't drag it relative to each other. You can see I can't move the lines anymore. Okay, dimension is fully constrained, but the sketch is not fully constrained. The dimension is where it's fully dimensioned, but the sketch is not there. I can't change the dimension here again by dragging it. If I want to change the dimension now, I will have to double click on this, on each of these dimensions, and adjust the parameters. Say like 80, type in enter. You can see it has adjusted. Right? That double click here and take it back to 100. Right? Alright, I can't change the dimension by just dragging it, but I can change the dimension by double clicking on that dimension and changing it manually. But if you notice, the dimension, me not being able to change the dimension is telling you that it is fully dimensioned. Okay, but the sketch itself is not dimensional. It's still shining blue, and you can see I can move it on the canvas. Alright, a sketch that is fully constrained, you cannot move them on the canvas. It will be black. You can't move it. Okay, so we are going to try and constrain this. So this is the origin of our sketch canvas. So I'm going to constrain the sketch to this origin using the coincidence constraint, which is the second one here. I'll click on it. I'll click on a point here. And I'll click a point here again. I'll click on the origin point. Good, perfect. You can see our sketch is now black, and the sketch line is now black, meaning that I can't move them. There's nothing I can move here. If I drag, it's not going anywhere. It's not going anywhere. You can see this is a fully constrained sketch. So it's always advisable. It's a good design practice. Not that if your sketch is not fully constrained that it will not work. No, it will work perfectly. But it's a good design practice. It's what we call professional way of designing. Okay, and I believe most of you are trying to be professionals. Are learning. You are not learning this skill for just for fun. You are learning. You want to be a professional. Okay, so this is a professional way of designing. It's good design practice to always constrain your sketch before you go ahead and extrude them. Okay, so we are done with this one now. So we want to convert it into solid body, and they say this sketch profile has to be extruded for a distance of 15 millimeter. All right, so we are going to extrude that, convert that sketch into solid body, 15 millimeter thick. So you can either click finish sketch here or on the sketch palette, click on finish sketch. We are now back in our solid design interface. So on the view cube, I'm going to click this home icon here to change it to isometric view. Okay, now it's now an isometric view. So we want to create a solid body out of this sketch. How do you do that? You go to your create drop down menu, scroll down to extrude command. Extrude is, you can use it to convert this into solid body. It's not just, this is not the only one you can use. You have other tools, but this is just one of them. So let's click on extrude to select it. By default, it has selected. This is our extrude dialog box. This is our extrude dialog box active. So I'm going to type in. If yours isn't selected, you can always select it because the option is to select the profile. Click on it to select it. But by default, sometimes Fusion selects it for you. But if Fusion selects the wrong one, you can just cancel that and select the one you want to use. Let's click again to select. You can drag it up and down to adjust the height of extrusion. Yeah. According to our example, say we should extrude for a distance of 15 millimeter. I'm going to type in 15 millimeter. Okay. Then taper angle 0, new body, yes, by default, new body. Okay. So this our final result, which is exactly what we have here. It's exactly what we have here. Okay. That's beautiful. So I'm going to go ahead and proceed with the second example because our time is almost fast spent. We have less than 20 minutes, I believe so. We have less than 20 minutes, like 18 minutes or 17 minutes more. Okay, so let's try and recreate this design in Fusion 360. This one is a little bit more complex than the first one. Okay, the reason I want us to do this one is because of your assignment. Okay, your assignment might not be as simple as this. Those of you that are doing AutoCAD should be able to reproduce this in AutoCAD. All right. I want to advance this Fusion course. You are learning this to be professional. So I would like to take you a little bit further. All right. So let's proceed. Okay, so we are going to first step is to create this. There are so many ways, or whenever you are trying to create a design in Fusion 360, there is no one, there isn't a single step or is a procedure you have to follow. You can start from anywhere you want. You can decide to create this circle first and then extrude later, or you can create this and then revolve. Okay, revolve is using the circular, revolve is like creating a solid body along an axis. Okay, so we've used extrude already. So I would like us to use a revolve command. So in order to do that, we are going to create this sketch profile. All right, let's proceed. So I'm going to create a rough sketch of this. I'm going to create a rough sketch that we dimension later, just like we did in our initial design. Right? I'll click on the plus icon to open up a new design tab. So then we'll create a sketch. This time I'm going to create the sketch on another plane. Go to my create drop down menu, select and scroll down to create sketch. Okay, I'll select any of this plane. I'll select this plane now. Now my sketch environment is now activated. So I'm going to create a free sketch of a free sketch of this. Then now I will constrain. I will now add dimensions later. Okay. I'll activate my line tool. I go to your create drop down menu and select clicking on line. So I'll start from the origin. Okay, I'll just try and create a free sketch. Something similar to that. So you noticed I did something here. I'm trying to create this, but rather than going all around, I just created half of it. Okay? Rather than going all around, you can create half of something and then mirror it to the other side. It will even make it much more accurate and make your design process faster. Alright? So let's go ahead and dimension it first. Then the first one is from this point to this point is 40 millimeter. It's 40 millimeter, yes. From this point to this point is 40 millimeter. That is the first dimension we are going to add. Then from this point, all right, to this point is 3 mm. So let's go ahead and do that. So the entire length of the model is 40 mm. So I'll activate my sketch dimension. I'll select from this point to this 40 mm. 40, type in 40, say enter. Beautiful. Then this point, so let me drag this downward so that all my dimension will be in one place. Okay, so next one is to add a dimension between this and this, which is 3 mm. Type in 3 and say enter. So the next one is to add the dimension between this and this, and let's check. Between this and this is 12 mm. Between this and this is 25. So we're going to do that now. Between this and this, 12. 12 mm. Then between this and this, 25. You can see the remaining one is 25. That's why you say that the sketch is over constraint. It's still 25. So you can say either create div driven or you can leave it like that. So we now have this now. Okay, but our sketch is not yet complete. So we've done the height. We've not dimensioned the width. That's it, or the thickness rather. So we're going to dimension this. From this point to this point is 25. So, but remember, we only draw half of it. So half of it will now be what? 25 divided by 2. Okay, that's one way you can get that also. Then this wider circle here is also what you have here. This wider circle is what you have here. And the outside circle is 50. That is this outside here. That's what we have here. Okay, let me see if I can. All right. Okay, this 50 millimeter outer diameter is the distance from here to here. Is the distance from here to here. It's also that's also the distance between of this outer diameter is 50 millimeter diameter. Okay, so we are going to fix that. So we have the 50 millimeter from here to here. And you remember we only drew half. So we are going to divide it by 2. 50 divided by 2 is 25. This other one, 25 divided by 2 is 12.5. Alright. So we are going to add the dimension from here to here. 12.5. 12.5. Say enter. Then we'll add another one from here to here. It's 25. 50 divided by 2, 25. Okay, enter. Okay, our sketch is not also fully constrained. We also have this parameter here, the distance from here to that point. You are going to look for that. Okay, that is this design here. So the distance, the thickness of this, rather the diameter of that, we are going to look for it. This is it. Okay, this is the thickness. This is being illustrated here in the design. So as engineers, you should be able to read and understand drawings also. So currently now we are drawing from an existing 2D diagram. So you can also have the option to draw from your head, off head, or from a physical object, and you have to draw. Sometimes you can decide to create dimensions for yourself, or you take physical dimensions. So the diameter of that one is 12 mm. So 12 divided by 2, because you're only drawing half, is 6 millimeter. 6 mm. So I'm going to dimension this 6 mm. So beautiful. Now we have this. So rather than create, remember I told you, rather than drawing the entire thing and risk the and waste your time, you will spend more time, and you might even have the problem of running into errors. You can draw just half of it and then mirror it to the other side. Okay. So how do you do that? You go to your grid drop down menu. Is the mirror command here is at the top here. You can select it, or you go to your grid drop down menu and scroll down to mirror. You can have your mirror is available in both your sketch environment and your solid design environment. Okay, so you can mirror bodies, solid bodies. You can also mirror sketches. So I'll activate my mirror command. So my mirror dialog box is active. So the first option is to object you want to mirror. That is, what do you want to mirror? I want to mirror this line, this line, this line, this line, this line, scrolling, zooming, this line, and also this line. Okay, then mirror line, the line you want to use as your center line for it to mirror to the other side. I'll select this line and then see. Okay, well, if you notice something here, this line here wasn't mirrored. We didn't select it properly. So rather than canceling everything and redoing it, you can always go back, use the undo mirror command. Okay, if it was in the design workspace, you can go back and then edit the mirror, but we're in the sketch environment, so it will only record after you've exited the sketch environment. So I'll select this, this is the third one, fourth, 5, 6, 7. Okay, then the mirror line is this. I'll say okay. Now we have this already. Okay, so we have this, so we can go ahead and extrude, or you can do something. You can let me undo this. Can undo this now and say finish sketch. Okay, now we have just half of the sketch, and use what we call the revolve command, which is this at the top of our toolbar. Or you go to your grid drop down menu and you scroll down to revolve. Revolve is just below extrude, select it. Okay, by default, Fusion will select it for you, but in case this is not what you want, you can cancel it and select the one you want for yourself. So I will select the sketch I want to revolve, then select the axis I want to revolve around. I want to revolve around the center axis. I'll select it. It will create a revolve operation for me. You can see it has revolved it. So this is beautiful. Say okay. So the next thing we'll do is to add a chamfer operation. There's a chamfer here, 1 by 45 degree chamfer. at this edge and at this edge. So we're going to add a chamfer operation. So rather you in chart this is a modification operation. You don't have to create anything again. So all you do is to go to your modify drop down menu and scroll down to chamfer. And select the edges you want to chamfer. You want to chamfer this edge and this edge. So you have two options. Type is equal distance, which is not what we want. We were given 1 by 45 degrees. So you want a distance and an angle. So you go back and change it from type to distance and angle. You have two distance, you have equal distance, you also have distance and angle. Then for the distance, you put in 1. Then for this, it's already set to 45. So you say okay. This is exactly what we want. So this is exactly what we want. So the next thing we'll do is before we conclude, I would like to show you under the modify drop down menu, you scroll down to appearance or you activate it using A. Okay, you can activate it appearance. Appearance is just to add color to your design. It doesn't affect the real it doesn't affect the real object of the design. It's just you can add any color you want. If you want to create a realistic image of that your design, that's why we add appearance. Appearance is also another name for color. Okay, not just color, appearance. You can add a wood-like appearance. If you are designing a furniture, you can add a wood-like appearance by scrolling down to wood. Okay, this is a sherry. You can drag it and drop. Okay, it's going to have a wood-like appearance. Have your bamboo light, drag and drop, wood-like appearance. So you can also add simple colors. Okay, you have the option to add appearance to do either bodies slash component or faces. Faces, you can add appearance to just faces. If I should change it to face, you can drag and drop on that face. It will have appearance to face. But if you select body, you can now have to add appearance to the entire body. So I'm going to use a simple